Here's a typical problem asking about physical versus chemical changes, similar to something you might see on the AP exam. It says, observe the molecular diagram above that shows a sample of liquid water. So we see the H2O molecule, oxygen being represented by red generally in this grayscale model. It's the gray atoms, and then the white atoms are hydrogen. Which diagram above represents when the liquid water is broken down to hydrogen and oxygen atoms? We need to pay attention to key words here. The first question asks about when it's broken down into hydrogen and oxygen atoms. And then the second one says, which diagram above represents when the liquid water is vaporized? And then which diagram above represents when the liquid water is electrolyzed to hydrogen and oxygen gases. So electrolyzed, and when you see hydrogen, oxygen gases, that's the most common state of matter. That's the state of matter of oxygen and hydrogen at room temperature. If you find them on the periodic table, they're in the section where those are considered gases, and something that you ought to know. So what that means is that's their most common form, and we know that they are both diatomic. So in their most common form, we're going to see H2 and O2. That's in their most common form as gases. So what we want to do for the first part is find which one represents just oxygen and hydrogen atoms. Well, that would be C. This one here represents the hydrogen and oxygen atoms, individual atoms separated from each other, not bonded at all. Which diagram above represents when the liquid water is vaporized? Well, if it's vaporized, that means it's still going to be the same molecule, just in a different state of matter, a gas. So that would be A, because we still see H2O. And then finally, if we look at the last one, when liquid water is electrolyzed into hydrogen and oxygen gases, we're looking for H2 and O2. That would have to be B. You can see that they are in pairs. Hydrogen atoms are paired up in molecules, and the oxygen atoms are also paired up in diatomic molecules. Which diagram shows that IMFs are broken? Intermolecular forces. If they are broken, that means that, if we're just talking about intermolecular forces being broken, that means that we still have water. Intermolecular forces are not the bonds. We don't have any bonds breaking, so that would have to be A. No bonds are broken. Then we get to which diagram shows that covalent bonds are broken. Now, if covalent bonds are broken, and it doesn't say anything about anything else being formed, we just have covalent bonds being broken, well, that means the water molecules would break apart into their constituent elements, which would be part C. And then finally, we get to the last one, which diagram shows that covalent bonds are broken and then new bonds are formed. Well, if the bonds are broken like they were in C and then new bonds were formed, well, that would be B. The new bonds would be between oxygen atoms and between hydrogen atoms. So we have O2 being formed and H2 being formed. All right, that's the end of that example problem.